GDG Kansas City's February meetup on prompt engineering. Just a raise of hands, who has been to a GDG Kansas City event before? Cool. So really glad to see a lot of new faces. So if you don't know who we are, we're the Google Developer Group Kansas City. So we host various events. We're trying to get back in the swing of monthly meetups, probably going to be about every other month or so. But we also have events like International Women's Day events and our annual developer conference that's typically at the end of the year. If you want to see any of our other events, you found us somehow, either Meetup or on the Google Developer event platform. But we're listed just about everywhere. I actually need to update this because we don't really do some of these anymore. But if you check gdg.community.dev, that's our main website that we post all of our events. And then Instagram we use, Blue Sky we're trying to start using, and then YouTube and LinkedIn. We typically post everything. And if you want to reference anything after this, we're actually streaming on YouTube right now, where everything will just be available in like our videos. So I guess I didn't say our names. My name is Jay Whitsitt. I'm one of the organizers of GGG Kansas City. We also have Kirti, who's going to present in a minute, and Roger Odell. All right, so with that, I'll give it over to Kirti.
Okay. So, as Jess said, I'm Kirti. We'll talk a little bit about prompt engineering, just because why not? So, this is a question to everyone. Have you ever been frustrated with responses that you were getting either from Copilot or GPT or Gemini, the earlier Bard, whatever the model you're using? So, how many of you have ever been frustrated with it? I have been too. So, any ideas on why? Anything?
I mean, a lot of reasons, but it might go off on a random tangent that's not what you're after, or just doesn't have the information that you're looking for.
Lack of information, definitely. So first thing is that AI models don't think or understand meaningfully. What do we mean by that? So all the models such as GPT and all, these are trained on millions of text data that is derived from various sources. Let's say, for example, I'm training a model on climate change, and the word climate change is often followed by words like global warming, greenhouse gases, carbon dioxide, emissions, and everything. So it learns a pattern that climate change is associated with these words. And every time we mention climate change, there's a high probability that your responses will have the words such as global warming. So as I said, they rely on pattern recognition and probability-based predictions. We'll see what this means in a brief bit. We are not going to dive very technically deep into how these models work, but I'm gonna just give a hint of introduction to those who just want to know how it's working in the backend. So most of the models rely on recognizing patterns within text, or if you're trying to make it do something that's reasonable or math or logic or reasoning based, even then it's trying to determine a pattern in whatever you're trying to ask it to do. And probability is one of the important things LLMs depend on. Everything is probability. Either they use one form of probability or a different. The math behind the way probability is calculated changes, but it's always probability and it's always predictions. Your GPT never knows what the next word for sure is. It's always a prediction of what the best possible word is it's going to say. AI doesn't see words as humans do. Like when I say water I had, you're able to comprehend that I had water, even if I'm like reversing the order of words or however I'm saying. Even if I say one word, some people are able to get context depending on how I'm saying it. But if I just tell ChatGPT a word, it'll give me a huge essay on what that word potentially could be. So they don't understand the way we understand. This is a little technical. Most AI models break down sentences into tokens. By tokens, we mean they're like small units of text. For example, let's say there's a sentence, I love ice cream, which I do. The tokens would be all individual words that are separated by space right here. Like either this can determine how your tokens are. You can use different delimiters to divide how your words are. But right now, all the words are divided based on wherever it sees the space. Now, these tokens, let's say I might be assigned a number 1, and then love might be number 2, ice might be number 3. Random numbers are assigned, and then for each number, how many times it appears in a document or in whatever the database it's working on, there's a probability assigned. And how these numbers are followed after each other, that probability is calculated. So every time you say something, the model is trying to predict what word should come next based on the probability of the text it has already seen. Okay. Let's see. Okay, even though AI can generate very convincing human-like text, it can, like, for example, if I ask it that I need some mental health advice, it might be able to convince me very empathetically that it's going to listen and understand to me. It's going to be like my best friend, but is it really comprehending what I'm saying? Is it able to understand the emotional burden that I'm going through? No, it cannot comprehend emotions. So, as humans, we associate words with meaning, experiences, and emotions. Let's say, for us, the meaning of fire, we instantly associate it with either fear or heat, but there is no association for word fire to an LLM unless you explicitly train it to be able to do that. It only understands words as tokens and probabilities and not using your experience or emotions. Any questions? So these are all the reasons why I was able to say. There might be many more reasons which I may have missed, but these are the best reasons why we are usually frustrated with AI, because it's not able to understand us, like on the base level. So when we humans speak or write, we intend to convey ideas, emotions, or persuade someone into believing what we are trying to say. But AI doesn't really have intentions. It's not trying to convince us. It's just mimicking the patterns that it has already seen in the past. Can AI truly be controlled to respond exactly as we desire? Any answers? Either a hard yes.
It depends on what you desire.
So this is an interesting picture that I found online, which depicts that AI is more like a puppet and we can control it. So my thoughts are mostly, not entirely, but we can strongly influence AI's responses with right techniques. So let's say LLMs usually use random settings to prevent repetitive or logic that's like using more robotic kind of language. If you have seen how ChatGPT has grown over the years, initially it would have sounded very machine-like, you could tell that it was not written by human. Us humans, when we talk or when we try to write, we are not like very grammatically prompt. We are not very structured in the way we talk. So you're really able to tell that it's not written by a human. Like you can say when you read it. Let's say an example. Let's say a book is written by an author versus something that's written by AI on the same context. When you read the book written by an author, you can tell how it's different because the way some words are either capitalized or emphasized, or exclamation points are used. For LLMs, honestly, caps don't mean anything. If I send someone a text, shut up in all caps, they will really associate it as me yelling at them to just shut up. But if I just say it in caps to LLM versus me saying it on all like lowercase letters, it doesn't really matter. So there are some randomness techniques such as temperature and top K or top P sampling, whatever you call it. So these are some values that determine how LLMs can be more creative or more predetermined, or how LLMs will choose repetitive words. For example, one word may be used as its synonym might be used somewhere else. It depends on a lot of these techniques. A top P sampling controls how many possible words AI considers before writing its next word. For example, it's saying, can AI be and blank? If it wants to write truly, it's considering all the possible options that it can output. Can AI be stupid? Can AI be unreasonable? Can AI be truly? So it depends on what it has already seen. So yes, back to my answer. I will say we can influence its response, but I believe we cannot completely control it, no matter how rightfully we train it, because it's always a probability. And so far, we have never trained an LLM to be 100% accurate. So how can we do what we discussed in the previous slide? One of the technique is fine-tuning the model for specialized data. When I say fine-tuning, let's take an existing model, let's say either Gemini. It's already trained on a very large data set. For example, I want it to be able to work as a therapist for me. What do? I use more data set that involves conversations of a person with therapist, or conversation of a person that's going through a rough mental phase, and I'm using those to train my model how to expect inputs and how to respond. What does it require? So when we talk about fine-tuning, it's often inaccessible or impractical for many users. Why?
Requires a lot of data
That's a very good point.
and hardware.
Yes. So it's inaccessible to many people because training large language model requires a lot of data and a lot of computational cost. So not everybody is, let's say, privileged to have all the resources they need to train those LLMs and fine-tune them to exactly what they need. Plus, technical complexity and lack of technical expertise. You have to be an expert in either ML field or very specifically in natural language processing to be able to fine-tune it to exactly what you're looking for. Time constraint. Would you take days or weeks to train a model just to do what you want, or would you try to use something that's more now kind of a thing? If you had to choose, would you choose weeks of training a model versus using something that's fixable now? What's your answer? Yes, we are moving into a world that's pretty fast. Like, we don't wait a lot. We can't even wait for some answer that we don't have. We instantly want to search it on Google. So what's the other way? Use of well-structured and detailed prompts. It requires no additional cost or no additional expertise, and we have immediate results. And that's where we are talking about prompt engineering. Prompt engineering is the art of designing effective prompts to enhance AI-generated responses. It's not really complex. It's just we are more trying to be why prompt engineering is important. So one thing is it enhances accuracy and relevance to what we are trying to obtain. Plus, it reduces the ambiguity in the way AI responds to our queries. And most importantly, it saves us frustration. And what are some techniques? Few short learning. We'll see what these techniques that I'm discussing in detail are. Chain of thought prompting, role playing, iterative refinement, negative prompting, and many more. And when I say many more, why? because these are some techniques that have worked for me. Prompt engineering is not really one specific technique narrowed down. It's what honestly works for you and for your use case. And we'll see later some demo that will show us exactly what we're trying to see. This is the context of what effective crafting of prompts looks like. We want to maintain clarity, context, be able to give examples when needed, keywords, and tone. If you're able to maintain these, we don't really need to use any predetermined technique. We should be able to use what works for us. So clarity tells your model to be very specific and direct instead of looping around something. And when you give context, it allows it to process some background information that makes it more relevant. For example, let me ask you a question. Do you know what citing is? Like, what is citing? No ideas? Okay, will you agree that citing is a form of referring to someone?
Sorry.
Yes. So citing is a form of referring to someone else's work, right? But will you also agree that citing is also a construction-based term that is used in houses, where the outer layer of house is cited? So, like, context is important. Like, in what context am I asking what citing is? So, examples. Not every time an LLM knows what you want. So when you provide context or when you provide examples, it communicates what your expectations are from the response. And when you give more keywords, it forces relevance to what you're trying to have. And tone is usually used when you're either trying to make it do some work for you. Let's see what a few short learning is. This is basically providing a few examples to your model so it knows how to respond correctly. Example, any thoughts on what examples could be? Honestly, there are a ton, but imagine you're teaching your friend how to write like Instagram captions. There are thousands of ways of writing caption, but let's say there's my favorite creator and I like the way they write caption. So instead of explaining how I really want, I can show them what I want. So an example, this is just a random example, rise and grind morning vibes for maybe a sunrise picture. Weekend relaxation mode for beach mode. And why it's useful, it helps the LLM understand the format, style, and structure you're wanting. When you give examples, it knows, it is able to recognize the patterns from those examples and gives you more relevant content based on those examples. Questions? Okay. Chain of thought prompting. This is not usually used if you're using LLMs for writing or generating content. It's more useful when you're working with math, logic, or reasoning. There are two types of chain of thought prompting. One is implicit. Implicit is when you ask your model to give a step-by-step reasoning before giving an answer. For example, I'm asking my model to calculate compound interest on a principal value. It may be directly able to give me an answer, but I want to know how it's calculating. What's the logic behind it? So when I ask my model to explain it, it will break down what it's doing in each step, and it'll be able to give you very minute detail of each step. Explicit reasoning is where you tell model what steps to follow to reach a conclusion. This is mostly used because when model uses its reasoning, it's already an existing reasoning. It's not your logic. But when you have a problem where you have a logic of your own, it's always important to tell your model in steps what to do. So yeah, as I said, it involves manually specifying the steps for the model to perform the reasoning task. Role playing. This is a very common method that has become very prominent for using in career enhancement services, such as developing your resume, writing content for your resume, or trying to generate content that involves expertise of some certain kind. So you ask the model to behave like a person or have certain expertise. For example, you're telling the model exactly that you're a cybersecurity expert. Now explain the importance of multi-factor authentication to a non-technical audience. So basically, what you're trying to tell the model is act like an expert. So it's going to gather all the data that's relevant to that field, whatever it can find, and then it's going to answer what you're asking. So it makes it more relevant to the topic you're asking. Act as a fitness coach and provide a 7-day beginner workout plan. When it is acting as a fitness coach, it is trying to gather relevant information and relevant skills that the person is having. So that's basically role playing. Iterative refinement is when you just don't take the first response that's given by your model, but refine it with further prompts. For example, let's say I am asking my model, give me an essay on climate change, let's say. It gives me a very huge essay. Let's say it's going maybe like 1,500 words, 2,000 words. I'll say make the response more concise. So it'll try to either narrow it down to either one paragraph, or I can add more information, make the response more concise and limit to 2 paragraphs, or limit to X number of words. I can ask to fine tune the output to certain things. And then maybe I can ask it to rewrite it in a different tone. Now here I can add few short learning and add more examples to illustrate what I'm trying or how the style of the output is I'm expecting. This is something that we use unconsciously, because whenever LLM doesn't give us what we want, we try to tell it like, no, don't do this, do this. So we do it very, in our subconscious mind, we do iterative refinement most of the times. Negative prompting is when you explicitly tell your model what you do not want. Then you know for sure that this is something I absolutely do not want in my responses. That's where you use this. You ask it to avoid undesired behaviors, styles, or outputs, and are explicitly discouraged in the prompt. For example, summarize the history of machine learning in an objective technical tone. That sounds good. That's what we want. Avoid informal language, oversimplifications, and subjective opinions. So I'm explicitly asking it to keep away from what subjective opinions are. And maybe I needed to present at a conference, so I'm asking it to avoid any informal language. Okay, these are most popularly used, but as I said, techniques are not limited to these. So any questions based on what we have gone through so far? Anything you feel interests you, or any questions or any thoughts?
What is I guess I'm just curious, for some of the, like, few shot is a really good example, but what's it doing to impact the probability of that it's returning?
Mhm.
Like, how is it influencing how the engine is returning?
So let's say I gave an example of example-based learning, right? Few shot learning. So there is pattern in the text it has seen, and that pattern differs. For example, maybe my text resources are from Wikipedia, from Medium. Everyone's writing styles differ a lot. So when I'm giving it structure, my way of speaking might involve structuring ways in a passive way. And someone might like it and want to use that way. So when I'm giving that example to the model, it's enabling the model to write using passive tone. So now the probability of words using I have done that kind of things, like instead of using directly I did it, we have done it kind of thing. So the probability of using that kind of tone and those words involved in that style increases when I say this is what I'm looking for. And I gave an example of citation, but citing goes pretty much to refer. I didn't know that there is some citing in the world of construction, honestly, till like one of my friends was getting it done. So if I don't tell an LLM what, we'll see in an example future that I'll ask it what is citing, it'll just use what's the most popular opinion, what its most databases talk about. But when I even help it a little bit that what is citing in terms of construction, it'll be able to give me more appropriate response because it's able to use the word house or construction to increase the probability of words that are related in that area. Does it make sense?
Yeah.
Okay. Any more questions?
There's actually one online.
Okay.
What's an effective way to link multi-line prompts?
Multi-line prompts. So one question I have is, do they mean like adding more space in paragraphs change anything? Because prompts generally tend to go into multi-lines. Would it change anything? But as long as you're able to do step by step on what is your priority, uh, whatever you say first will be given more priority because it processes in a sequence. It's not processing like everything together. So as long as you're able to convey, this is what I want to do first, this is what I want to do next, as long as you're maintaining that clarity, multi-line prompts don't have a lot of difference. There is no, whenever you go to a next new line, LLM is not processing that as anything. When we visually see it, or we can see it's a different paragraph or it's a different subsection or whatever. But for LLMs, that means nothing, honestly. It will convert the entire text into one list of all words. So it doesn't really matter. It's based on what you're trying to focus more on. Does it answer their question?
I think so. Okay. There's another one. Could you list a few more types? I think you have that in your slides. So we can just send out the slides afterwards.
Okay.
But then I suppose during the conversations, the types can change. So do the responses types get mixed up as the conversation moves forward?
Okay. So I do think, honestly, as I also mentioned before, let's go back all the way. Oh my God. Okay. So when I mention many more, I'm also saying that prompt engineering is not limited to these techniques. On the right-hand side, I have included a picture that says like what is important to be able to craft effective prompts. It can involve combining multiple techniques, such as first, I might give it examples of what I want, but then I might use iterative refinement to tell, oh, fine tune it in this way. I want it to be this way. Or later I can say, oh, you're using this thing a lot. Maybe you're using the context of global warming a lot. Avoid using global warming and then talk about what's the impact. So you can always combine multiple techniques to be able to work for your situation. There is no standard rule that says this is that only works. It's always determining what works best for you. And as long as you're able to convey what you want to the LLM, that's what like basically matters. The key is to be very clear, specific, and most importantly, literal. I can say LLMs don't understand indirect form of, let's say, let me think of an example. Okay, someone is frustrated with the weather, let's say, and I decide to say, oh goodness, it decided to snow again. I am not really saying it in a good way, but when I say it in the same way to an LLM, it won't understand that it's a frustration that I'm trying to say. So I will avoid talking in any indirect context to an LLM. I will be as literal as possible. I'll say, I hate that it is snowing again, instead of saying, oh goodness, it's snowing again. So yeah, there is no one technique. It's what works best for you. You can combine multiple techniques. There are also a few other techniques such as zero short learning and a lot more other techniques that are not mentioned here. These are some things that are popularly used and more common because they just tend to have more awareness. And these techniques are based on how you can make someone understand what you're trying to say. So I have only discussed 5 because I thought these cover various aspects of what you can combine to be able to write your own prompts.
There is one more question.
Okay.
Thank you for your time. Can you actually mute your speaker, and I'll unmute my mic so that I can just hit your turn volume down. To blast out your speaker. No, I mean like turn your volume down on your Mac.
Okay. Does that?
Okay. So there's one more question. Do different words carry different weights? For example, how does the LLM respond to the word build versus create? Does this differ by model?
It definitely does. As I said, LLMs are trained on data. There is something called data bias and data variance that introduced in most LLMs. So let's say I have trained my LLM on historical texts that talk a lot about building certain things, building temples, building monuments, building churches, building wonders. So if that is used a lot, it will not understand the difference between build and create. But if I'm able to provide enough data set that is able to create the variance between build and create, it will be able to use those words in an effective way. So far, since most LLMs are trained on huge amounts of data, there is nothing that has not gone into these days LLMs. If you have ever written an essay as a child, I'm pretty sure if it's on the internet, it's gone into one of those LLM trainings. Even if you're embarrassed about it, it's still there. So since it has seen so much data, it's able to understand most literal context in everyday life, and it's able to distinguish between build and create. And the probability of it using build and create will again differ based on context. If I'm talking about construction, bridges, and everything, it will give more weightage to build. Whereas if I'm talking about interior designing or architectural designing, it will give more preference to create, depending on the context again. So the probability will change always based on the context you're giving it. Okay. Yes.
Like when we are asking the questions to the LLM, so sometimes it's doing like same, giving the same answers to the number of persons. Like we need to prompt again and again. Like how to rectify it.
So I know that happens. Every time you try to say that it's doing something wrong, it doesn't understand. So that's where you have to be literal, and using step-by-step process will help. When we go to hands-on, I'll show one of my prompts that actually broke ChatGPT, and it started printing number 1 for 1.5 hours. It just kept printing number 1 forever. Like, I don't know why. And it was such a lame prompt for me, at least. So these are a few exercises that I have particularly for you to be able to think what you would use. And I would really love if you would give what technique would you use kind of feedback on this. So let's say you need help with an academic writing that has some guidelines and a tone of writing. The task is write a prompt that helps the model produce responses according to your needed structure and tone of writing. What kind of technique we discussed today, or will you combine multiple techniques? What would you use? Yes. No one? Yes.
I might use few shot.
Yes.
Give it an example of the tone that you're looking
Okay. Yeah, that's a very good part. And yeah, primarily I would use few shot too. And any more? Yes.
I think role playing would work well too.
That's
a academic writer or
Yeah.
postgrad.
That's a very excellent point. Any more?
Is Q shot one where you give them examples?
Yes.
Never mind.
It's fine, yeah. Like example-based learning is also few-shot learning. So whenever you give examples, it's a fancy word, few-shot, but most commonly people do use example-based learning. Yeah. Yeah, that's a very good way to, since we are doing academic writing, we want to avoid use of certain language. So that's a very good way of writing negative prompting. So yeah, let's move to the next one. You want to explain the importance of saving money to two different audience. One, a 10-year-old child. Two, a business executive. Your task is to write two separate prompts to instruct a model to tailor the response for each audience. What technique would you use?
I would probably use role play and have it say, based on Dr. Seuss, da, 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 and it would end up writing a Dr. Seuss limerick for the
Okay, and?
I'm pretty sure all of their books are already up there.
Any more? No?
Maybe the negative one,
Mm-hmm.
especially with the child one, you want to keep it within a certain style.
Yeah.
Somebody online said iterative for child as we need more time and simplest way to understand.
I like that. I really like that. One thing I'll really do for child is use an analogy, such as if you want to buy this toy that's worth $10, you have to save so much from your either pocket money or something. But if you end up spending everything on candy, you're not able to buy the toy that you really want, and maybe have it write something on those analogies. So again, few-shot learning. So, but I will not do that for business executive because they don't want candies.
Children can have a lemonade stand.
Yeah, they can definitely have a lemonade stand. So since children have the tendency to learn based on their desires, so I will probably ask my model to do that. But I really like the responses you all have. And trust me, there is no right answer for any of these. All of your answers are right. This is, I think, the last one. What technique would you use? You want AI to write a motivational quote about success, but you don't want it to use common cliches like never give up, hard work pays off, because everyone says it, guys. Like everyone says it, that hard work pays off, but yeah, it's a sad reality. Write a prompt that ensures that responses avoid those phrases.
I think it would be a good chance to use few-shot to give it examples of more creative, inspirational work, like books or things.
Yeah.
That veer away from the simple.
Yeah.
Probably combine it with the negative too.
Yep. Yeah.
Yeah.
You have a paper, don't use any of these, don't use any of these slogans or whatever.
Combined with role playing, pretend you are a famous, speech giver.
Yeah.
You're told not to plagiarize.
So yeah, those are a few good techniques, and always, like, you have to determine what works best for you when you're working on something. Let me quickly see if I'm able to. Yes, I can take them.
So there's a couple questions online. How is data being ingested into these models?
Like, how do the models work on the data?
And I guess related question, are the models trained on non-structured data? So just how are the models trained?
Text is always non-structured. Text is never a structured data. What we call structured data is when we have something that's pointing to something. Let's say face recognition. If there's my data, they classify me as either subject A or subject B. When the data is labeled to be something, that's when you call it structured. But if there is no expected output, then it's always unstructured. So LLMs are always trained on unstructured data. The whole text way of using data is always unstructured. So yeah. But the irony is you can always prompt it to give you structured outputs. So the data goes in as unstructured, but you can always have structured data come out. Does that answer? Okay. And let's see. Give me 1 second.
Anybody have that 200 subscription?
Oh, no.
I'll let the press use it first, report on how it is, and then we'll see.
Honestly, nothing we are doing today will involve a $200 subscription. When you use the subscribed model, most of these models in today's world are trained to have advanced reasoning and logic built in them. So you'll expect definitely better responses, but sometimes they can still break. So let me, okay. So my task is I am trying my LLM to generate, I have a data range between either 0 to 499 or 0 to 4,999. I wanted to give me output of how many number of folders start with each digit, like how many folders start with the number 0, how many folders start with the number 1, how many digits are there that start with number 2. So let's start with Gemini. I am saying calculate the number of numbers starting with each digit between 0 to, let's stick to 499. And I'm specifying to include the value 0 and 499. So is this visible to everyone?
And maybe
Is this better? So I just gave it a prompt that I just had in mind. I want to calculate numbers starting with each digit in the number range. And it's literal. I haven't given it any instruction. I haven't added any more context on what really I'm expecting or how the data is distributed. It broke down. We are working with numbers from 0 to 499. That means we are dealing with 1 digit, 2 digit, and 3 digit numbers. Okay. See, it said there are no numbers that start with 5, 6, 7, 8, 9. Is it true? So it says there are 100 numbers that start with 0. I mean, in a way it's true, but it's not really true because it's assuming something that is not said. Now, let me try to do... how do you do it? Yeah. What am I doing here? I am explicitly specifying how to do it. Do you agree that this is something that requires reasoning? This is a task that requires reasoning, right? Okay, let's see. Okay, in step 1, it generated all numbers from 0 to 499. We're considering this. In step 2, okay, here in step 2, what I specified was get first digit of all numbers from step 1. In 0 to 9, the first digit is simply the number itself, which is correct. And when we are analyzing, are these results? Yes, they are. It worked. So, and I have what also, this fails when I'm doing this for larger range, such as, let's say 4,999. So do you see? Because here it's making an assumption that it has to pad everything that's beyond first digit to multiple digits. So what I can do is I can iteratively either tell it that do not assume to pad zeros in those numbers, or I can do an iterative, like there's also one form of learning where you can ask an LLM if it's true or not. Let me try say you said there are no numbers starting with 5. How about 5, 50, 51, and so on for rest of the digits? Let's see if it improves. It said it apologizes. And it didn't really do anything. It just said, my apologies, I made an error. But yeah. So either we can break down, and also last night I asked ChatGPT to do the same thing in the exact same prompt. In the step 2, when I asked it to get first digit of all numbers, after printing 0, it just started printing 1 endlessly. It was just stuck. It was not able to print anything else. But these are some things that I just tried on. These prompts can always be refined more. Any questions? The goal was to show you demonstration of how some things can improve.
I'm just mostly curious, with that step 1, you probably tried it a couple times. Did it ever actually generate all the numbers? Because in the example,
It doesn't print all of the numbers, but actually GPT did once. Okay, let's do this. Also, I am not using any premium versions of anything. These are like, oh, it did not. Does that work? Also, most LLMs kind of assume that either you're looking for some sort of data when you ask them something that's reasoning based. Here it directly prompted, I'll write a Python code for this process. I don't really need a Python code. I want simple reasoning. So like, this is where I'm showing that it's not definitive that every process works. It's a process of improving your prompt and trying to convey what you really want to your LLM in a repetitive process. Iterative prompting is something that we'll always use. We'll always try to improve our model's responses, because why not? And one of the techniques that recently got really popular is asking your LLM to write a prompt that will work for it. It works if you're using advanced LLMs, but for the free LLMs that we have access to right now, it doesn't really work because it doesn't know what it really understands. So it's a technique that a lot of people are saying that why not just ask the LLM to write a prompt for it? It will write a prompt, but it will not write in a way where it's able to understand its own prompt. So that is pretty much it. That's like what I wanted to talk for today. I think I did go a lot over time, right? No? Okay. Ooh. So that's like, let's try something part. I wanted to show how that one example really breaks a lot of LLMs thing. I really thought it was pretty simple when I first had that problem in my mind. But when I prompted, that's where I realized that a lot of LLMs do get confused with it. But if you try to be more specific on saying, oh, when I'm defining a range of numbers, do not pad them with zeros. Directly, if you give it more context, it's able to always provide better results. So, questions? Do you think this helped? Yeah.
It sounds like there's some problems with the math in some of these LLMs. Are there any peculiarities that you've seen between how different LLMs address those? Like if you ask them to start counting, will one of them start from 0, one of them start from 1, or would there be a difference in how they interpreted?
Right now, the models that we are working with are not really trained explicitly on reasoning-based data sets, like nothing that involves a lot of math or anything. So when I ask them to count numbers, most LMs will assume integers because that's most commonly used number format. But it also, as I said, it depends a lot on data set that it sees. I can
It does work pretty well with data analytics type.
Yeah.
I was telling them earlier, I was using it, Copilot to help me with my course material for data analytics. I actually had it calculate probability on something very specific, and I kept refining it as I was going through, and I told it, show me how to do this with a calculator. Because my students are going to be working with regular calculators. I'm not going to be doing anything. Nobody's going to use paper. I mean, I will, but they. And so I literally had it tell me, what digits to press and everything to get the answers. It didn't always work, but I got some of it to work. Or tell it to use like algebra as opposed to like trigonometry or something higher in math. So you can get it to kind of do that kind of stuff depending on, like she says, the data set you're trying to accomplish. But basic data analytics stuff seems to work pretty well.
Yes. A lot of startups, a lot of people who work in this space, they're using these, we call them foundation models that are trained on the large data sets. What we do is we take these foundation models. For example, let's say I have a data set that's more on reasoning, like math reasoning and all. I'll fine tune the existing foundation model to do more math. And most people are deploying them. There are so many things that are being built on ChatGPT API, that are being built on Gemini's API. So what they're basically doing, they're just using the existing foundation model and they're utilizing the data they have to be able to tailor these models to specific use cases. I'm pretty sure this is a case, but oh boy. It asks you to sign up. But when you browse through GPT's models, you are able to see what other people have curated using GPT. For example, someone might have created something that's more specific to writing part, like if you are looking for writing needs. So people are fine-tuning them to their own needs. Again, it's more on data availability. Fine-tuning a model is not for everyone. And specifically, when you're able to make the current existing models work for you, you don't really need to fine tune models because it also involves a lot of technical expertise. Plus, you have to do a lot of testing that it actually works in your scenario. So even if you have enough data to train, you might not have enough scenarios for testing it. So there are a lot of things that can actually go wrong. So I am a student who researches mostly in the space of deep learning, and right now more on the large foundation models. I do a lot of fine tuning, so I know how tedious it can get when you have to re-fine tune your model because it's just not performing as you expect. My research involves a lot of retraining these models and finding the data set that works for me. One of the things that frustrates me a lot is data sets because I don't find enough data set for my use case. So either I have to work on collecting data, and if I'm collecting data, I have to again go through the process of filtering data, cleaning it, and making it usable and more understandable, and get rid of anything that's unwanted in my data set. So it's a whole process of pre-processing your data and preparing it for your models. If you're interested in it, I mean, it's really fun to do, but it's frustrating too.
Where do you said you're doing? Where do you study?
I go to UMKC.
Okay, yeah, I work there. Maybe I'll talk to you afterwards about some.
Yeah, sure, definitely. Yeah, I go to UMKC. I'm pursuing my PhD there.
So there's one question online. One of these suggestions I hear for using LLMs is to start with a task that you do routinely and offload it. But given the chance of hallucinations, how would you suggest approaching this? How reliable can results be from a well-formed prompt?
So yes, hallucination was really a greater problem in the older versions of the models. They were hallucinating because they were never trained to limit on what they do not know. But a lot of ethical impacts have been taken to limit such responses. For example, in the past, when ChatGPT was really new, if I ask it to cite something, it'll just make up some random author's name, some random author's, just a random that it'll make it sound so relevant that you'll feel that it's actually existing. But the thing is, it's hallucinating. Hallucination often happens because it doesn't have enough limitations in the parameters that go behind the training part. If you want to really avoid hallucination, you can always ask what the sources that the LLMs are using to give you the data. Most LLMs give you what sources they're deriving their data from. But if you really want more credible results, always go for example-based prompting and negative prompting to avoid anything that's like it's not sure about. If you're not, there's something called confidence level. Confidence level is when your probability is above certain limit, that's where the model becomes more confident that this is true. So you can negative prompt the LLM model that if you're not confident about this, just don't give me, only give me content that you're absolutely sure about. It's not 100% sure, but it'll increase the chance of credible, valid results. That answers? Okay. Any more questions?
So is there any specific technique for generating an image?
I haven't worked a lot in image space, and trust me when I say this, most image generating generative AI right now, I am not a huge fan of it. They're still like working a lot on it. The image generation techniques that I worked pretty much are like direct models. I train GANs and diffusion models to be able to generate those. If you find any models that are trained on diffusion techniques, those are the best images I have found so far. So I'm not a fan of DALL-E. One thing is there is much more text data as compared to image data. But every time you're doing your capture thing, you're giving them more image data for them to train their models. I always had this feeling that we should be paid for doing the captcha because we are doing them. We are giving them so much of free, credible data. Have you ever been authenticated for doing a wrong captcha in the past? I'm pretty sure you have. That's what they have used to train their models. But yeah, image generation techniques are still a lot under progress. There's a lot of academic research, but there is no like end product research right now. So yeah.
There's a pretty cool website that ties into Discord to image generation. And some friends of mine and I on Twitch one night had a lot of fun playing with that, trying to get it to generate some of the crazy. You could give it an image and tell it, like I gave it a picture of myself, like the one I have on the beginning of the slide here. And I told it to, make me look like a Viking. And it would like put a weird helmet on me and all this stuff. Really a big long beard, something crazy. Then we would ask it questions like, make the Incredible Hulk look like a dark Jedi. And it would end up looking like Yoda. Like some crazy responses that same techniques we're talking about here. You have to play around with it to get it. I mean, I was using it to generate an image once for something, and I was being serious about what I asked for, and it did not look right at all.
And
I could draw better.
One thing that doesn't really work for image generation is iterative prompting. When you tell that improve this part, it doesn't take the old output and give you something that's based on the exact output. That's because when they give you images, they're not really stored somewhere in the database that it can retrieve. They're more like it's cache. They don't store it. So it doesn't really know which image you're referring to when you say, oh, I really like the previous image, but can you just tweak this tiny part and give me back? It will never give you the same image ever again. Also, one thing I really feel about, there's a lot of there's a lot more advancement in terms of like face face-based AI generation, because deepfakes have evolved like tremendously in the last since 2016. So there are many more models that are able to produce realistic faces as compared to producing realistic other images, like anything. Either you're asking it to produce posters or produce landscapes. So there's definitely that bias because more research has been focused on facial data, and there's a lot of face recognition data available online as compared to other data sets. So yeah, you'll find pretty good images that either will generate a professional headshot of yours or do something. They are good models, but I don't like synthetic image generation parts as much.
Yeah, I know, like that particular website also, I think their models also understand classic architecture and art. Like if you say, generate this thing and make it look like a Picasso did it, they have enough data because they have all of these images of paintings that Picasso did to generate something that looks similar to his, but not exact, right? It's the style. And so I know like there were artists that were worried about having their style being ripped off because it learns how it does it. But I know, at least from that particular site, that they've taken a lot of technique from like the classic artists from like hundreds of years ago.
Yeah. And when we talk about image, there is a lot of bias that exists in current data sets. It's hard to mitigate those bias in a world where we strongly talk about being inclusive, being a lot more things. So I definitely think there has to be a lot more research on them. Even when we started talking about spoofing techniques or presentation attacks for face recognition, they were not able to, those were not really working on people of color. So that bias in data sets also make it harder for those models to be generalized for everyone. So we need to understand that for image, it's a lot more complicated than just text. Text bias does exist, but it's not as much. In text, there's only negative or positive bias, but when it comes to people, there are a lot more bias that exists. People come in all shapes, all colors, all kinds. So a model has to be effectively able to address these biases. That's where a model becomes more popular. Generalization is something that's most companies are working on, just one model that works for everything.
Just to go back to the very beginning, you talked about all the LLMs are based on probability of the next word,
Yeah.
basically. When you talk about reasoning for math, is it using the same techniques to do that? Like, obviously our data sets are full of text, but
It is also still probability because it's not doing math. It's not using a compiler that calculates something exactly. It's understanding some words and it's predicting something based on what it has seen, what it has known. It knows how to do addition. It knows how to do subtraction. It knows all the basic mathematical functions, how they're performed. It feeds on those formula. And whenever we input something, it's trying to replace that formula with these values and trying to predict, oh, this could be something. If you really try to give it a very complex mathematical problem, I don't know how many of you are familiar with this, but there is a cryptographic function called SHA-256. I try to prompt GPT to generate a mathematical inverse of that function because it knows a lot of mathematical formula. So I thought it would be able to calculate, but it's not. Why is it? If it has the knowledge, it should be able to honestly generate an inverse of the function. But it doesn't have the knowledge. It knows that this is an existing something that could be done into this. So it's always a probability.
Okay.
It's not intelligent.
That's what I figured. I just was curious about that because I know that they obviously these companies are seeing that people are trying to use it for that, and so they have to adapt, but it's difficult. when
One
they're
of-
not just doing that.
One of my first instincts when I really understood reasoning and logic for LLMs, my first instinct was to generate an inverse of SHA because it has been something that nobody has been able to crack so far. It's a one-way function right now, but if we have enough computing, there could be an inverse. Nobody has been able to solve it yet. So I don't think they're smart. They're still probability.
Just get that quantum LLM.
Yeah. Yeah.
Some of the earlier AI models were trying to do things with ontologies, trying to create some sort of reasoning based on an actual understanding of the world rather than a probability. What's happened to that research now that LLMs have caught fire? Are there LLMs that are trying to incorporate that, or is that just something that's everyone's abandoned?
Honestly, based on, since I'm someone from academia, I don't think LLMs have caught fire. They just got viral because it's like more, GPTs have existed for a long, long time, but they became popular when user-friendly version came out. So since that came out, now a lot of people are talking about LLMs and making it more accessible because someone made it accessible. So that research is still continuing. This is how I always, when I look at machine learning, it's building mathematical functions that are harder to predict. But when I look at natural language processing, it's always probability. So even though one is subclass of the other, they work in different ways. Just don't come at me if I say something wrong.
So there's no LLM out there that's actually trying to incorporate ideas from ontology.
You can combine, there's something called multimodality that's becoming really popular, where you can combine outputs of two different models and build it as one model. If that happens, we can always combine logic with probability and logic with reasoning. But there's still a lot more research to go to make them think like humans. Human thinking pattern is not something that's easily replicable. So reasoning is something that's harder to achieve in LLMs. They work on fixed formula. Most of them are mathematical approximations of every formula. If you take one of the basic examples of machine learning, it's called Hello World of machine learning, is California house prediction, house like price prediction. It's called Hello World. So we are trying to generate a mathematical function that can approximate all those data points. So it's not really reasoning there. It's not predicting something. We know we are trying to adapt or an equation to be able to do our task. So it's mostly math. Does it answer?
That's a pretty good, that's a good start.
Yeah.
I'm also a little curious, whenever you use cloud computing, you're trusting someone else with your data. And those vendors are trying to simultaneously improve their models.
Yes.
If you inject proprietary data into that LLM, where does that data potentially end up?
It is definitely ending up in one of the databases that you'll never ever find and never ever be able to destroy. Whoever, like whenever we use cloud, people think that I'm not physically storing my data anywhere. You're not storing in your physical space, but it is somewhere still being stored in a physical space. So if you're giving a proprietary or very confidential information to LLMs, it's definitely going somewhere. If someone wants to dig it, they will, but do people care enough to find it? That's an important question to ask. Most LLM guidelines say do not give any sensitive information. Whenever you read or accept those terms, they always say that they are not responsible if any of your important data has been leaked, because it is you that is providing information. So it has to be a very conscious choice. Yeah.
Yeah, so I'm somewhat curious because there's a certain individual who has a LLM in-house that he's using that he suddenly has access to huge amounts of federal data. And this individual doesn't seem to respect laws around classified information or privacy or financial disclosure. And so I'm wondering if we will potentially see classified federal or private data inside of Grok in the near future.
So this is what I believe. Anything that goes onto internet stays forever out there. Either someone is making different copies of it. It's
Oh, no, you go on, but after you.
okay. Yeah. So laws are being made over use of artificial intelligence for sensitive data. And in the past, if you rightly prompt LLMs, it would have done something to give sensitive information, maybe some of it's source code, but people are improving the privacy techniques, like securing techniques, to be able to protect that part and not allow LLMs to give any sensitive information. It was not regulated in the past, but a lot more rules, regulations, and laws are being made around authorized use of artificial intelligence, and those who do not obey will definitely have to be like, we can try as researchers, we can try to make it as secure as possible, but finally user decides what they have to do with it. They choose what route they want to go down to, so I can't really comment for them.
If the data is encrypted properly, those models will be able to actually do anything with it.
Yeah.
They'd be passing around a whole bunch of encrypted.
It's the government, it was plain text.
Well, I was gonna speak to that a little bit. I mean,
It depends on, I worked on a contract where we did simple.
Oh my God.
So I'm on the whole, but Android and phones and stuff, so I know that there's. As long as you don't give them an hash key.
well, and one thing is they actually have government cloud systems that are supposedly isolated. I don't support what's going on, so I'm not encouraging that kind of behavior, but you can deploy LLM models that are on government cloud.
Yeah, but it's all very mysterious to me, because if they were looking for fraud or waste, they would have sent in attorneys or accountants with fraud investigation backgrounds.
Yeah.
That's not who they're sending.
Oh, yeah, I'm not disagreeing with you on anything. It's not, I'm just saying it's not going to OpenAI or Grok's databases necessarily, or Grok, I suppose it seems.
Well, I mean, just look at the amount of proprietary data that companies were having to submit to the Consumer Financial Protection Bureau just for the agency to approve their contracts. And now, who has that data?
Yeah.
The world's richest man who happens to want to start a payment platform, and now he has all of his competitors' data.
Yeah, data. Most people pay a lot for data. Data is the most valuable resource in this growing world. And a lot of us are giving our data for free when we are storing some things. The way we are giving a lot of patterns that humans think about. So as much as there's research on encryption techniques, protecting your data techniques, non-invertibility of data techniques, there is also parallel work that most people do in the attacker's perspective that they can do to hack into a certain system. So it's always more like two sides of a coin that always go parallel with each other.
So crafting effective prompts for smaller language models can be quite challenging. What are some strategies that can help improve the quality of prompts and enhance the small model's performance?
Can you repeat the question again? I have to.
Yeah. So basically, smaller language models have a harder time. Crafting prompts for those can be quite challenging.
Yeah.
Just some strategies to improve the prompts to get better output for those smaller models.
So one thing that I have noticed is I have shown how two different models react to same prompt, right? So when you are prompting your model, you'll understand the way it responds. You as human are able to recognize those patterns. If you can play into those patterns, that's a really good way to be able to understand what your model is doing or where it's like more aligned towards what it does. Other than that, if you're talking on smaller language models, most of these models are tailored for specific use cases. Most of them. I'm not saying like all of them. But if they are tailored for specific use cases, then I think they really work better for those use cases. But one thing is to iterative prompting is something that works in this case, understanding how the model is outputting and trying to convey what you want in an effective way. Also, if you ever try telling a model that it's wrong, it will never accept it, guys. Trust me. It will never take the fact that it's at fault. It will try to apologize, but it'll do everything, but it won't correct itself. So you'll have to find a way to ask it to do something that's it not doing. For example, let's say when I gave a prompt to count numbers starting from each digit, right? I have an option to say, okay, that's an answer, but I can say, oh, this is what I'm exactly expecting. One more thing I can do is example-based prompting there. I can say, for example, in the numbers range 0 to 29, the number of numbers starting with 0 is 1, number of numbers starting with 1 is 11, number of numbers starting with 2 is 11 again, number of numbers starting with 3 is 1, and so on. When I give that example, it understands the pattern that I'm looking for, and that's where it works effectively. So example-based and iterative prompting. Okay, good. Any more questions? No? I hope this was helpful. Thank you. Thank you very much.
Yeah, so the only other, unless you want to introduce it.
Yeah.
Okay.
So next month, March 15th, we are celebrating International Women's Day. Just because we are celebrating Women's Day doesn't mean that you're not invited, guys. We are trying to celebrate women in technology. We'll have a keynote panel discussion, and we'll have an amazing workshop on understanding bias and how to mitigate that bias in a work environment. So it's going to be a training that's happening, and then we'll have a speed networking followed. It's almost like it's on a Saturday. It's from 10 to 4, so almost like a day. We'll have food for you. Like we'll still have food for you. It'll be an amazing chance to just make connections and network with people. So it's going to be good. So I would say register and hope to see you there. Is that good?
So we have this room for a little bit still. If you guys want to hang out, chat, please take food. Otherwise, one of us has to take it home.
So is there any other kind of AI type events that you guys are interested in? Or gonna be doing others in this area? Or anything related to